we had a Mythbusters thing, me and Bruce, where we basically took a JCM 800 and we took every single element of a JCM 800 to try and identify what bits of that pretty simple valve circuit, but with quite a lot of complicated interactions going on, which bits were important, which bits we weren't. And part of those, we did some really, really crazy tests. And one of them was around output transformers.
Hello, boys and girls. As you can see, I'm not in my studio. I'm not even in Germany. I have come all the way to Northampton in the UK to the headquarters of Blackstar Amplification to talk about guitar amps. I want to talk about the past, the present, maybe the future of guitar amps. You guys have sent me a whole bunch of highly interesting questions, and I'm gonna pass them on to this gentleman who used to work for Marshall and who founded, something like 20 years ago, Blackstar. Ian Robinson. How you doing?
Nice to meet you.
You've been doing this for a while, right?
As you say, we've been doing Blackstar since 2004. We left Marshall. We launched the company in 2007. So it's kind of 16th year now. But I started at Marshall in 1996 when I was 26, straight out of university. So basically, just over half of my life I've been working in guitar amplification and guitar amplification design.
So you see, he's the right guy to answer your questions. And let me just say this before we start. The reason for coming here is not only that, as you know, Blackstar makes some great sounding tube amps, and you know that I've been using a Series 1 EL34 in my studio and in some of my courses. But to be fair, there are some other companies who also make some great sounding amps out there. But for me, Blackstar has always been a highly innovative company, and especially lately, some products have caught my attention, some very smart products that seem to be pushing the boundaries between analog and digital, between tube and solid state. So that's why I think this is the right place to ask those questions. Let's get started.
Cool.
First one, very, very interesting. So, and I think several people have asked this. Why are tube amps louder than solid state amps?
We did a lot of research on that very, very question right at the beginning of Blackstar. So should mention Bruce Keary was our technical director. He was Marshall's technical director, kind of genius electronics guy, but also no bullshit guy. So we did an awful lot of research on that. The reason why is that a valve amp is able to produce more volts across the loudspeaker load at specific frequencies. So a loudspeaker, its resistance or impedance varies with frequency.
Yes.
And that's why you get like a bass bump resonance and you get a presence lift. And the way that a valve amp, the output of a valve amp, interacts with a loudspeaker allows more power to be produced at resonance and at presence. And the actual amount that you need is about 2.5 times the power of a solid state amp to reproduce that additional power at resonance and at presence. And that's what our TVP, True Valve Power patent that we did for the TVP amps, that's what that was all about. So it's not about producing power over the whole frequency band, it's about producing additional power at resonance and at presence, and that's what gives you that special thump and that sort of sparkle in valve amps.
So it has to do with the impedance curve between the
loudspeaker, and how a valve amp is able to drive the current into the loudspeaker in a way that a solid state amp can't necessarily. You need additional power in a solid state design to recreate the same effect, which the way that we do it in TVP is actually, it's kind of a linear power amp, but we have 2.5 times the power available, but we don't deliver it at all frequencies. We just deliver it at the resonance and at the presence, and that recreates that additional power that the valve amp does kind of naturally.
More power amp questions. Many bass amps use Class D amplifiers. What is a Class D amp, And why do we hardly see it in the guitar world? We do see it here and there, but...
Yeah, so a Class D amp is, you know that there's various what we call classes. So there's A, Class AB, Class C, Class D, and then further variations. And Class D is basically a switching power amplifier. So people think it might mean digital, but it doesn't mean digital. It actually means switching. And what you get there is you get very high frequency switching circuit, which generates in a very efficient way a high power output, which is smooth through a filter circuit. I suppose it was originally used in industrial applications, probably not in audio, certainly not in our kind of audio. But the great thing about Class D amps is that they're extremely efficient in terms of heat. So you can get a very small Class D power amp that generates an awful lot of power in a small compact package, very lightweight. They don't necessarily sound great, but what they do give you is they give you loads and loads of power. And then it's what you do with that power to make it sound great. If you get what I mean?
Because you can make it sound great.
You can make it sound
But what's the reason?
Very great.
Like is the average guitarist too conservative to accept a Class D amp design, or why don't we see more of it?
Well, I think because it maybe in early applications, the application, the technology wasn't great. So for instance, they would tend to be, you could say very dynamic, i.e. not have much compression and stuff. So you'd expect them to be very fast, right? Which for guitarists sometimes isn't exactly what you want.
Yeah.
And the other thing with them is the way that they overdrive is really not beneficial. So just due to their technical makeup, when you go outside the safe operating boundaries in terms of signals, you get horrible distortion, right? So in a valve amp, one of the beautiful things about a valve power amp is when you approach distortion in the valve stage, you get compression, and then you get very nice harmonic series, which is pleasant to the ear. Class D is almost the opposite, and you get almost like if you clip a usual Class D amp without some additional processing, it sounds really fucked up. It sounds like some instability, like some zzz and some really horrible noises. So what we do is part of this same thing as we discussed before, but it's a great way of generating power. So it gives you the raw kind of horsepower, but then it's what we do with that engine to make it something that's, you know, that, to extend the metaphor, that's a pleasure to drive, right? So, and what we do is, again, that's around this TVP patent. So it's the best way to get the 2.5 times the power that you need for valve amp is to use a Class D, which gives you the power cheaply, efficiently, lightweight, low heat, but then you'd put the processing around that. So what we do is we never let them clip, and in most of our designs, what we do is we precondition the signal before it goes into Class D with all the clipping, the compression.
So you get that elsewhere?
And we do it before, and the TVP patent basically says we do that resonance and presence part, and the frequency dependent power delivery is all done digitally, and then you just have a big loads of power Class D at the end, which basically that's job is just to produce that in a linear way. And all the non-linear stuff's done
has been done elsewhere pre that.
Yeah.
Interesting. I think we have one more power amp question. Does power amp distortion, and now we're talking about high gain metal, even matter in an age of tight high gain tones where all distortion comes from the preamp anyway? So how important is the power amp in that world? In my brutal chuga world? This
is a brilliant question. So the first bit is the frequency aspect. So the power amp of a valve guitar amp is not linear in the frequency domain. So you get the presence and the resonance, which is really super important to guitar tone. Now you may get that in a modeler, but it will be included in the model. If you've got a good guitar sound, that has to be part of the sound. So good guitar sounds mimic that. Even if it's solid state or digitally, they all have that as part of it.
That's frequency?
That's frequency. The second bit is the dynamic bit. So the dynamic bit is the compression element. So you could say, okay, well, really sort of very dynamic, fast metal playing, you need a very, very fast power amp because it's all about dynamics. It's all about stopping the note, starting the note, how quickly that can trigger. And I sound like an engineer, so I'm predominantly a metal player anyway, so I kind of get that about keeping things tight. It's kind of what I've been about all my guitar playing life, really.
Good.
But I think if you don't have any of that, then you'll miss it. If you don't have any compression and you just go through a big Class D, which is clipped maybe with some hard diodes or something, you're probably going to find that a little bit tiring on the ear and the playing experience. So some of that dynamic bit's important. And then the last bit is, and this may be important or maybe not, I get it, that most of the distortion for sort of high gain metal comes from the preamp to keep it tight. But actually sometimes, do you want to just dial a little bit in of that messy kind of
saturation
additional stuff coming from the power amp? And maybe sometimes just have that little bit of what you say, like lack of tightness, flobbiness. You know, that you get. That's the brilliant about Series 1 dynamic power reduction, is that you can dial in at any kind of volume a little bit of that if you want to. And it's kind of quite a subtle thing, and it's all person to taste, isn't it, really? Yeah,
it's great because you got the flexibility to go for it or not, right?
Yeah, especially with like a big amp like that, because you can keep it really tight if you want, or you can soften it up.
And can you make, that's the follow-up question, the last power amp question, can you make a 20 watt or whatever, 10 watt, like tube amp sound exactly like its, whatever, 100 or 200 watt counterpart, like at a lower volume? Because I can see like some of the tightest sounding metal machines. Let's take a Diesel Herbert or something. They have a huge power amp, is it 150 watts or something? Not to drive it super loud, but to be able to get fairly loud, but still stay
keep it tight,
right? So do we really need that, or can a 20 watt tube amp sound as tight as lower levels? Is that the same?
Yes, definitely.
Okay. No difference, like.
Yeah, I'd say so. I think so.
So if it's not about, well, the question is if somebody is recording, where it's not about, loudness or something, being loud in a rehearsal room or something, because then you can get away with a smaller amp.
Yeah, I'd say so. Yeah, I'd say so. It's interesting. So that's all about really the gain structure of the amp. So it's how much, once you've got your clipping and distortion in the preamp, how the gain's set up driving the power amp. So you've got to have a lot of control, because as you say, you're going to try and keep that, well away from clipping. I think it is interesting though, a lot of what we found actually quite recently is when we've been doing some research, especially on EL84 based amps, so which can quite often be those 20 watt amps, 30 watt amps, like 18 watts and stuff like that. So 6v6s and EL84s, we do find that they have a very transitional sort of overdrive characteristic. So actually those amps, I think it's to do with the type of power valve they are and the transfer characteristic. They actually start to compress and distortion at quite low powers, whereas with the EL34 and 6L6, our kind of research says is that they actually stay cleaner for longer. So I think if you were going to do that, I would probably be looking at something like our HT20 or something like our old HT20, where we use EL34s in cathode bias because they stay cleaner longer and then they clip. Whereas if you're going to use an EL84 based amp, I think it's going to be more progressive. So you'll always have a bit of that softness about it.
Let's talk about transformers. Let me read the question. Where is it here? The legend says, the more iron, the better. Is it true? And how does the output transformer affect the sound? Is it like the bigger, the better? We can see some...
Massive. So, really, really excellent question. And it's something that we did a load of research on in the beginning days. So I don't know if you know, but for the first 3.5 years after the Marshall days, we were just basically in my garage winter and summer, we could only afford to eat baked beans, which was pretty dangerous in a small confined shed with me and Bruce. But hey, it gave us loads of time to go into this stuff. And one of the things we had a Mythbusters thing, me and Bruce, where we basically took a JCM 800 and we took every single element of a JCM 800 to try and identify what bits of that pretty simple valve circuit, but with quite a lot of complicated interactions going on, which bits were important, which bits we weren't. And part of those, we did some really, really crazy tests. And one of them was around output transformers. And what we found is the output transformer size affects, one of the things it affects is inductance, which affects the low end response of the output transformer. So in particular, if you talk about the size in that way, and the amount of iron, then that would affect the low end. What we found is we had a local UK transformer manufacturer build basically the same spec but in different sizes. And what we found is we had to go to something really very unusual to have a really obvious audible effect.
Okay.
So I think what we found was over a certain size, then getting bigger and bigger and bigger won't make much of an audible difference. And you'd have to go quite a long way the other way for it to really mess the sound up. We did find a lot of difference between different grades of laminations. So the higher grade laminations, which was more to do with the top end. And then we also found that there's a big difference in high end response between small output transformers and large output transformers, and something which is kind of a secret of the way we do things at Blackstar led us to understand some stuff around power amp distortion, because small output transformers form a tuned circuit with the loudspeaker, which small output ones, which mean that post power amp clipping you get an additional low pass filter which removes fizziness.
Okay.
So that's why when you listen to an AC15 or a Marshall 18 watt and you drive the shit out of the power amp, it never sounds completely like being a jam jar. Zzz. Whereas if you do that with
the high end before
it's a filter post the power amp, which is kind of impossible to do because there's no electronics past the power amp.
Yeah.
But it's the output transformer
with the speaker interacts and
which interacts. And then on a bigger amp, that's why when you listen to a Plexi overdriven, do you know when you really drive them hard, there's a really kind of metallic, very, very high end fizzy bit, which some people like, and it's part of the characteristic sound. That's because that parameter in a larger transformer moves that filter out of band effectively, so you can't hear that filter. And it's a really, really important of the way that we shape all our Tony Blackstars is to do with that tuned.
And that also
filter.
means when you do something like this,
yeah,
you emulate all those effects, right? You might do.
We might do, and that might be a very important part of our secret.
Maybe.
But it is really, that's, for us, we love that sound of, we don't like fizzy stuff, right? But we love the sizzle without it being fizzy. Yeah, it's sizzle, so it's got to have that presence, but not that detached high-end thing, which some metal amps like. That's kind of not our scene. It never has been.
What defines the character of the preamp distortion? Like some are tight and fast and dynamic, some are rather loose and or fuzzy or something.
Yeah.
Like, how do you voice a preamp, and what defines the character of the distortion?
Wow. Yeah.
I have time.
You're gonna need it.
My flight goes back and I say,
So there's certain kind of parameters which are in all preamps, guitar preamps, right? And this is, out of all the design work, this is the bit I can probably speak with the most authority on, because when we did all the original Blackstar circuits, Bruce did most of the power amp and power designs power amp designs and the clever stuff that could blow me up. I was too scared, so I just did all the preamps, which were less dangerous.
Okay.
And also, to be fair, I was kind of I played guitar since I was 10 or 11 or 12 or whatever in that style, right, for all my life. So I kind of knew what that should sound like. And I had the electronics degree, but I wasn't a great electronic engineer. I was a decent guitarist. Bruce was an amazing electronic engineer, but he didn't play guitar. So we were like really good partners like that. So I did all the original Blackstar preamps because I was doing the voicing. And actually we did a load and load and load of work at the beginning about what was important. So you've got gain, the distribution of gain, and you've got distortion generating components, say. And then you've got pre-gain clipping and post-gain clipping, and you've got pre-gain filtering
and
post-gain filtering, and balancing those are the main parameters that you have. I always sort of say that what's the truth on this stuff, right? So actually you can make diode circuits sound good, you can make FET circuits sound good, you make valve circuits sound good.
Yeah.
Honestly, if you listen to a valve preamp clipping on its own without any shaping around it, they can sound awful.
Okay.
They can sound equally as bad as a diode. It just depends what you do with them, okay?
So the shaping or the filtering is what makes...
It's very important. It's not everything. And so the progressive nature of valve clipping is important, and it's an extra thing.
Yeah.
But you can make valve preamps sound pretty bloody awful. You know what it's like if you try and overdrive, say, an old valve desk or something, the distortion gets pretty zzz.
And you can make it like a JFET thing or like sound pretty nice, right?
We've got I've been working on JFET stuff since like I started Marshall days actually, and I've one of the like little area specialism sort of thing that I'm into. It's balancing those things off. If you put too much pre-bass before the clipping, then you'll tend to get
a more fuzzy or loose or
a loose sound.
A
loose sound, for sure. If you want to have a resonant bass and like a really nice presency top, you've got to do that post clipping. A lot of it is to do with, so the pre-bass is super important on a high gain circuit. That keeps the thing tight.
Okay.
Now, the amount
how much bass goes into the distortion?
Yeah,
right? Okay.
Into the distortion element, like diodes or valves or whatever you're using. And then actually, in terms of the high end, a lot of the high end shaping pre-valve, for me, affects the stability, because you want to take, it's not really that affecting the overall tone afterwards, because after the distortion, you can't hear that part of the filtering. So you take high frequencies out to keep the thing stable, because there's so much gain a lot of these circuits. The other thing is when you turn the guitar, the only time you can hear, especially the high end pre-shaping, is when you turn the guitar down. Because if you've taken all the high frequency out, once you go below clipping, it just becomes a circuit like in your Logic,
Yeah, makes sense. Yeah, makes sense.
Like you can imagine your Logic high frequency.
I never turn down my guitar there.
Exactly.
Sorry.
Exactly. Well, like clean channels are only for tuning up, right? You know, that kind of thing.
Yeah.
So that's that bit. But then, so you want to keep a nice tight over like distortion response, let us say. The distortion characteristics will affect, so whether it's a FET or a valve or a diode, will affect to some degree the compression part of it, I would say.
Okay.
So you can make that progressive or not, so softer or not. Yeah. But if you're really, really overdriving it, really, 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 they all become more similar. But then afterwards, you really hear what's going on afterwards in a high gain circuit.
Then you hear the smallest amount of filtering. Right?
Absolutely, because you're generating such a wide
pink
frequency.
Noise or something like that.
And then if you just move things, in the sensitive band of the ear. So that's where you do the shaping, and that's why Marshall preamps became the basis for all high gain preamps afterwards, because the tone stack is after the clipping.
Yeah.
So you generate this big harmonic series of noise, and naturally, by design, the Marshall preamps allowed you to shape everything afterwards when it's effective.
Yeah.
Whereas in a Fender, Fender circuit, then it's pre-gain. So for clean sounds, that works really effectively, but for overdrive sound, it's kind of useless.
Not much happening, right?
Yeah, it's kind of useless.
I think the only amp that still has that high gain amp is the Mark series, right?
Yeah.
From Mesa. They still have like this pre-gain tone stack. Talking about tone stacks, active versus passive EQ.
Yeah. So both can work really well, actually. So the thing about the passive EQs that we all use in guitar design, they're quite basic. And from an engineering point of view, they're pretty poor in terms of performance, because the main thing that we all hear about with guitar tone stacks is the interactivity between the bass, middle and treble. So as you move around each of the controls, they affect the other controls. But that's what gives it that natural feel.
Yeah.
But if you were designing a good 3-band EQ in any other circumstance, really, you wouldn't want them interacting, because I want to go in bass, I want to do middle,
in a console or something, right? Yeah, you don't want that.
So the original Fender designs, so from Bassman through to Twin, then Marshall did the same thing, same circuit, effectively the same circuit, different values, and you know that the Marshall EQ is a little bit higher. The Fender EQ mid-dip is lower, so that gives you a different, that's part of the British characteristic, is that higher mid-dip. But they're all kind of pretty much the same circuit with the same interactivity. And generally when you're talking about active EQs, you tend to not have that. You have more distinct control over the frequency bands, and you can do things like, as you know, go back to your kind of Logic recording stuff, you could change the Q, so you could change the width of the EQ, you could change how sharply they cut off, so you've got a lot more control. But sometimes that doesn't sound very natural, so sometimes you have to be really careful using active EQs with guitar tone. I'll give you a brilliant example of one that really works, is Marshall JMP1. So the Marshall JMP1 is fully active tone controls, but it's all pre-voiced with a prefixed Marshall EQ. So it's a valve preamp.
Yeah. With JMP, I'm just thinking, is that the golden preamp?
The golden preamp? Yeah. Okay, sorry, I should. Yeah, I'm showing my age now. But that.
No, I know that one from the '90s or something.
Yeah. It's a great, still a great product. Yeah. And so anyway, without going on too much, that was done really, really intelligently. So the guys who designed that, it uses a prefix Marshall tone stack, so you still get kind of the basic sound is still what you'd expect in traditional, and then sitting over the top of that is an active tone system, and it's actually very traditional, sort of what you'd see it's an adaptation of what you'd see in a recording desk or something like that, but it's done with good ears and with sensitivity and not being too radical. Man.
I remember Adam and me talked about that preamp yesterday, and I gotta check it out again because I liked it. I remember playing it, like their big EL34 power amp and the golden rack system. Yeah, it was good. When you design a new amp, something like this, or when you design those ones, like how do you voice them? Is it trial and error? Do you have like a sonic vision, something you want to achieve, or or is it a mix of both?
When we started, we didn't really have what is a blackstar sound, So it's really interesting now when we do all these products. I think we kind of now have a kind of our own kind of history now. Yeah. So there's certain elements within our preamps that we always use. Yeah.
For example, OD1, OD2, that's what I've learned today, right? Yeah. You can see the two main high gain distortion characteristics like coming back in different forms, digital and analog, tube, solid state, like everywhere, right? So you have, so that is the blackstar tone and you...
Yeah, and it's brilliant, right? So it's something I suppose I could be proud of, about the work we did in the first instance. And it's brilliant that the guys are respectful enough in a way to do this. It's like, for instance, Paul Stevens, who's our chief engineer, who's been designing amps forever, a lot longer than me, a lot more experienced than me. And, he says when he designs a blackstar, he uses our kind of recipe because it's Blackstar. Okay, so, and he likes it as well, and he respects the way it sounds. As you say, there is a lineage now for us across all the products that use the same things. Super, super important is that all goes back to that initial research phase. So that initial research phase, that 3.5 years plus the decade before there, we all, you know, I was working really closely with Bruce on so many different things. That discovery phase is where we came up with all the things that are different about Blackstar. So big point for us in the first instance was when we did our research, we weren't doing it because we wanted to be different. We did it because we wanted to understand. And we always said we wouldn't change the traditional designs for the sake of saying we're different.
Them, right.
We kept what worked perfectly. We kept the things that we thought we could improve. We improved, and sometimes it's a little bit about personal preference, and sometimes it was just, you know what, that bit doesn't sound very good, and we can probably do it better. And then we researched, and that was that thing I described earlier about let's have a crazy set of output transformers so we can actually hear what the inductance of the transformer sounds like, really, instead of just what we read in books or what people say. And there was loads of them, so I'll give you a few examples. Can I give you some examples?
Yeah, please.
For a laugh. So, cathode follower as the tone driver. Diesel or Bogner or Boogie, they tend, certainly most of the Marshall stuff, all the Marshall stuff has a cathode follower. And that does a thing. It adds some clipping, and it's frequency dependent clipping. So it clips the high end more than it clips the bass. So you get a slightly fizzier top, and you also get a more open bottom, right? So it kind of cleans up the bass and clips the top end. And that's to do with the inadequacies of it as a circuit. But it's something people love. Yeah. It's just one of those valve amp things. Yeah. And what we ended up doing is when we listened to that, we like the bass tip up. So it's almost like you get on the microphone where you get a bass tip thing, depending on where you're singing or whatever. But we didn't necessarily like that really hard edged clipping that you got out of the cathode follower. So what we did is we designed using a different type of tone driver, which is more linear in terms of clipping. But then we just add what we did originally, certainly Series 1, we added a prefixed bass boost to emulate the bit we liked out of a cathode follower.
Okay.
So that's what the whole process was around these original designs. It was about...
So always a combination of like technical research and then just like
and then these.
Personal
and
preference
then,
by ear.
Loads of it was like saying to Bruce, yeah, but we like that and we don't like that. How do we do that? And then he'd go, and then you go away and the next day you come in and come up with some genius thing. Like, for instance, ISF, for instance. You know, the ISF thing was around, well, we want to bring some top artists.
So maybe explain it first. So if people don't know, it has been a part of the tone stack right from the beginning, right?
Yeah.
So when it's somehow shifting the mid frequencies, and you tell me more.
Exactly doing that, yeah. And so, you know, like we spoke about earlier on, the Fender Bassman tone stack and the Marshall tone stack and the PV tone stack, and it's pretty much the same circuit with the values changed, and changing the value changes the response overall, predominantly the mid dip, and that's part of the characteristic of the amps, a big part of the characteristic of the amps. And the way ISF came about was we knew, well, one thing, we knew we had to come up with a passive EQ circuit because people love that interactivity between the different types.
And they're used to it, right?
Yeah.
It's just like what people expect. Yeah.
Absolutely. So, this is honest story, and it's pretty funny, really, is that we were thinking about how we could get artists to come on board with us, like big name artists, because we were very lucky having left Marshall. We could talk to people and they'd listen to us, you know. So if we bring Gary Moore to my little garden shed and we say, hey, we want to voice an amp just for you. This never happened, by the way, but we did do it with other people, say. So big name artists like that. How do we could give them a Marshall tone stack or a Fender tone stack or Boogie, you know. And the idea was originally we were going to build these chassis up, which would have different gain stages different voicing mechanisms, you know, parameters, and lots of tone stacks. So we would have like 10 different tone stacks. And we have some pretty complex switching things, and we could switch between them and go.
So you could A/B stuff and
yeah. So you want one of those and one of those and one of those and one of those. We basically, I said to Bruce, you know, well, is there any way of basically having that as a continuous control? And then the idea was that somebody would come in, they would say, I love that. We would then measure where that control was, and then we would remove that control and prefix it, and you'd have bass, middle, treble in that position. And this is a true story. And then we said, well, do you know what? Maybe we should let people choose where their tone stack is. We came that way around. It was technical research that ended up giving us something really useful that we thought everybody should have. And then we said, well, let's get 10 guitarists to set up their tone stack using the ISF, and they all wanted a slightly different mid-frequency. So we said, aha. And anyway, you were talking about how we voice amps. There's a lot of stuff in our amps which allow you to have more control than in a traditional valve or even solid state design. I could tell you there's some really fucking interesting stuff. Really, really.
We got do a few more videos, I think.
Yeah.
2 questions left. 2 questions left.
3 hours remain.
3 hours remain. It's always I'm amazed.
Mate, you shouldn't give me all that
forever.
cocaine.
It's great. Something that also several people ask, what makes an amp a good pedal platform?
Yeah.
So
flexibility in the preamp and flexibility in the power amp, I'd say, is dead important. So
and a really clean, the possibility to really drive it clean. Like people use whatever high watts or amps like that. They're known to be.
Yeah, although
you know I mean?
some people love Vox as a pedal platform, and they're not that. They're one of those products that I say are never really, really clean. They're always doing something almost. That's what we learned. So,
and that really depends on how you balance like the output of the pedal and the input gain of the. There's a lot happening there.
Yeah.
So I thought people tend to use rather clean sound. But
no, I think
continue.
I think you're right. Yeah. I think they do, but I think so. Our St. James EL34 amp is like our, I'd say, best example of pedal platform.
And this one, isn't it?
And that one as well has the similar sort of stuff, the similar sort of circuits in it. And so what it does is it does very clean. So on the St. James, you have one mode is very, very clean, which is quite Fendery. Then you have another mode, which is more Vox-like. And that is never quite clean. Not completely, even if it sounds like clean from a distortion point of view, there's still some compression going on.
But it preserves the character of the pedal, or is that the idea? Or
I think the Fender one probably does. And the Vox, I'd say the Fender one accentuates a lot of stuff because you got a lot of bass, you got a lot of treble, and a big mid dip as well. And I think that could get quite boomy if you're using, depending on what your preference is. You put a lot of gain into that, it could get quite boomy. With the Vox one, I think it's more sort of, because it's quite compressed and it's a little bit more sort of balances everything out, I'd say. And those are 2 voices.
But that means you have 2 options. So it's like, though I haven't played it. It's like the white or gray version
it's over there.
It's over there. You can see
There's one over there, yeah.
You'll see it in B-roll now.
Yeah.
And, right. So those are like 2 ways of clean.
Yeah, and they cover off. I think they cover off a very dynamic, very active feeling EQ and something that's more compressed, borderline crunch if you want, because the Fender stays very clean. The Vox is always on the verge of that crunchy, adding a little bit of stuff. And for us, traditionally those are the 2 main pedal platforms. But what's going on with those is it's not just the preamp we're changing. So there's 2 really important things. So with the Fender, you have the tone stack with that sort of topology. It's not exactly a Fender, but it's that in that sort of direction. But then you have quite a tight power amp with feedback.
Okay.
And with the Voxy one, with that sort of more Voxy sort of sound, you have the tone stack, it's kind of more unusual tone stack in a way, but I think the mid dip is higher, and there's more preamp distortion, but the power amp has no feedback. So on that amp,
so you're switching the whole circuit.
we switched the preamp and the power amp at the same time. So Paul Stevens did an amazing job of putting all that into one box, and that does come back to the thing we were talking about, power amps and all that stuff earlier on, trying to emulate that. But when you go into the Vox sound, it has all that sort of chimey top end, sort of bell-like top end, actually quite a resonant low end. The Fender seems to have more low end in a way, but a lot of that's coming out the preamp. So it's how the two things interact. But you've got to do the preamp and the power amp to get both, and that's why that amp gives you pretty much the broadest possible palette of traditional of pedal sort of platform sounds.
Final question, last question. The future of guitar amps, especially tube amps, like, do we still need monsters like this? Do you think you will be still making amps like that in 10 years or something? Or have we come to a point where both digital and like solid state or whatever, emulations or like alternatives have reached a point where we don't really need this anymore? And plugins maybe, and modelers, the whole world of different digital.
It's a really interesting question. We're involved in kind of all those technologies, which is a great thing about.
That's why I'm asking.
Blackstar. Thank you. So my own opinion is that there is a place for valve amps. I think part of that is market requirement, because some people will always want those traditional amps. There's something to do with the simplicity of a valve amp, which allows it to, not for any magical quality, not because some higher force, just because they're more simple, there's less filtering going on. It's they're more open, more natural sounding sometimes. And you can do that as of digital emulation, but we tend not to go down that line. We tend to go towards more. We have tended to go towards more complex stuff. And I'd say, so part of it's market perception. The other part of it is, especially with these amps, the amount of power that you generate, actually it starts to become maybe attractive to, like a 100 watt amp or like a 200 watt amp. To do that in Class D, you can do it, but there's a lot of messing about to get it to do what these do naturally.
That means if you want to move some real air.
That's exactly what I was going to say. You know what it's like to stand in front of a proper 100 watt valve amp with a 4x12 and experience that. Yeah. And I don't think there's a modeler plus 10,000, 10K PA solution that will deliver that same feeling. And at the end of the day, I think this is really important. At the end of the day, it's all about moving air at the end, isn't it? Yeah. Like, you can model everything. Yeah, at the end of the day, it's about that going through a speaker and moving air. And the valve power amp bit and into the loudspeaker and the cab bit and that feel, I think that's, I wouldn't say it isn't unmodelable, but it's possibly unbeatable. and it's easier to achieve. The closer in a way, you end up in a situation with that sort of power and that sort of setup, it's actually easy to use a valve amp. Yeah, right. Maybe, yeah.
It's just heavy.
Yeah. St. James gets around that. And the main reasons for the weight are not to do with the sound, because, so in St. James, we've used an SMPS power supply. So that's like a switch mode power supply that you'd find in a laptop or anything, but highly adapted and made to produce extremely accurately the same power supply response as in a valve amp. And we've reduced the weight by a load. Yeah. So in the future, I think we will continue to produce traditional, very heavy valve amps because some people like that. But I think we're going to do more of the St. James type product, because then you get all the advantages. You get the great sound, you get the trust that people like, but it's usable. And that for us, that's a big, you talk about the future. It's it's kind of it's almost like a new category, we think.
Best of both worlds kind of.
Yeah, isn't it? It's like not intelligent valve amps, but it's something around that, connected valve amps. There's no reason why you can't have an amazing sounding valve amp that you can plug into your computer and get all the sound directly to tape and use it live and all that stuff, and that's what we're about. It's trying to push that forward and make them still continue to make them relevant. We're pretty passionate about that still.
This has been amazing.
Cheers,
Thank you
mate.
so much.
Thank you. Sorry for going on.
What a great enlightening discussion. Thank you very much. So next thing I will do, I will check out a lot of the Blackstar high gain amps that we have around here, and probably I will do another video and compare them and have a lot of fun with them.
Oh, great.
Yeah, so please leave a comment and yeah, ask more questions, and then I will return here and meet this wonderful tube amp.
We'll feed you more
expert
fish and chips
again.
and give you more ale. Nice one.
Thanks again.
Cheers, mate.
Thanks for watching. See you in hell, motherfuckers. Bye-bye.